So the only way to get better at finding definite integrals is to practice. So I'm going to do with you a couple here. I encourage you to maybe stop the video, give these a try on your own, and then you can press play and see if you got the right answer, or just follow with me as we go. So we're going to add this general power rule in reverse. So we're going to add 1 to this exponent, so -2 plus 1 is -1, and divide by -1. And we're going to evaluate that at 1 and at 2 and subtract the 2. So that means that I'm just going to simplify this before we go. So that's 1 over x evaluated 1 and 2. So it's the top one substituted in first, subtracting the bottom one. And I would always use brackets because it's so easy to mess up these negative signs here. So we've got -1/2 plus 1, which is 1/2. So the integral between 1 and 2 is equal to 1/2. Let's do a second example. I'm going to write this integral as an exponent because that makes it easier for me to do the antiderivative. I'm going to add 1, so that's 1/2, and divide by 1/2. So dividing by 1/2 is like multiplying by 2, so I'm going to do the flip and multiply at the same time. And I'm evaluating between 1 and 4. So I'm going to plug the 4 in first, minus the 1. And this is 2 square root of 4 minus 2 square root of 1. This is going to be 4 minus 2 equals 2. So the integral is 2. So moving on to what looks like a little bit more complicated example. But we're going to take the integral of 3 over x, which is 3 log absolute value of x. So we have to take the absolute value of x because we can never you can never take the log of a negative number. So really the integral of 1 over x dx is always the natural log of x. And if these are positive in here, like if we're going to 1 to 2, we don't have to worry about it. But since these are negative values, we've got to make sure that we don't run into trouble. So here we go. We're going to now evaluate this between -e and -e. So we've got 3 absolute value of log -e squared. So there's the first one. I actually did that wrong. I have to input the first one in there first and then subtract the second one. There we go. So the evaluated the top boundary, subtracting the evaluated at the bottom boundary. So the absolute value will take care of the negative sign, and natural log of e is 1, natural log of e squared is 2. So we've got 3 minus 6, which is -3. And let's take a look if that makes any sense. Y equals 3 to the x is an inverse graph. It looks something like this. And if we take the integral between -e squared and -e, that means that we're calculating the area like that. And that should be negative because it is below the x-axis. So let's do another one. And here I've got a piecewise function, so I'm just going to graph what this looks like to give us a visual. We've got the function is equal to the sine function between 0 and pi, and it's equal to y equals x on this side. So we're looking at basically the area between here and here. And this one we could have done without using a calculus. We could just take the area of the triangle, but this is the area under the curve of a sine function, so we're actually going to integrate. So the way we do piecewise function is we do it in pieces. We say, all right, we're going to integrate between -pi and 0, and we're going to integrate this function. and then we're going to add that to the next one. So that starts at 0 and goes to pi of this function. So we separate it into two pieces, just like the function is separated. So this is x squared over 2 evaluated between negative pi and 0 plus the cosine x, and it's negative cosine x that will produce a positive sine x evaluated between 0 and pi. So now using brackets, it's 0 over 2 minus negative pi squared over 2. Here we go, I've got to square that and make sure there's lots of brackets there. So that's the first bit. And now let's do the cosine. I'm going to put square brackets around that. So that's the first bit. And then I'm going to add. Next one is negative cosine pi minus negative cosine 0. All right, so this is simplifying, and since I'm going to do that up here, so this is 0 minus pi squared over 2. Cosine of pi, think about the cosine function. Cosine of pi is negative 1, so this is going to be minus negative 1, and plus, because a negative times a negative is a positive, and cosine of 0 is 1. So evaluating that one last time, I get negative, or simplifying, not evaluating, 2 pi over squared plus 2. So there is my